Here's a science passage from the reading comprehension section. In this video, as I mark up the passage, I'm going to pay special attention to words like but, however, yet, and although, because they're going to tell me that an important contrast is about to be discussed. I'll also try to call out the most important claims and conclusions in the passage, as well as the different points of view of the various people who are mentioned. At the end of the video, I'm going to sum up the entire passage and recap some of those annotation techniques and how they might help us as we approach the questions. Okay, let's go. In the early 1900s, most astronomers mistakenly believed that 66% of the sun's substance was iron. Okay, so mistaken belief that 66% of the sun's substance was iron. Okay, as a graduate student at Harvard University in the 1920s, okay, that's when we're talking about, Cecilia Payne, later a professor of astronomy there, argued pioneeringly that the sun is instead composed largely of hydrogen and helium. Her claim, though substantiated by the evidence and later uniformly accepted, encountered strong resistance among professional astronomers. So that's our introduction. She has a claim that encountered strong resistance among professional astronomers. So she had some trouble getting her ideas accepted. The orthodox view that the sun was mainly iron was buttressed by the knowledge that Earth and all known asteroids contain iron. Also, the evidence from spectroscopy. What's that? A technique used to identify chemicals by the distinctive spectral properties of the light patterns they emit when heated to incandescence. Okay, the evidence from spectroscopy was generally taken to show that iron was the predominant element in the sun. Okay, so that evidence is supporting the argument for iron. But how could a body composed largely of iron generate the huge energy output of the sun? Okay, that's a big question that people were trying to answer. The eminent British physicist Lord Kelvin had hypothesized that the sun was continuously contracting and that the resulting compression had raised the temperature of the sun's materials sufficiently to account for its enormous heat. Okay, so Lord Kelvin had a theory. It was the contraction and the compression that raised the temperature of the sun's materials to account for the heat. However, given the usual assumptions about the sun's size and rate of contraction, it followed that the sun's age would be about 20 million years. Evidence from the fossil record, however, strongly suggested that the sun had warmed Earth for billions of years. Billions of years. Millions? Not so much. The fossil record tells us that it was billions. For Payne, this meant that the iron hypothesis had to be re-examined, together with the extensive spectroscopic data alleged to support it. So she didn't believe that the iron hypothesis could possibly be right, and so she wanted to look at the spectroscopic data again. Preliminary examination of the spectroscopic data convinced Payne that they lent themselves to multiple readings. Okay, she's on a case. She's found some evidence. She suspected that preconceptions about the sun's makeup as being mainly iron might have led to skewed interpretations of that data, and this led her to subject the data to rigorous critical scrutiny and review. So she thinks that preconceptions led people to interpret it in a certain way. Analyzed without preconceptions, she found, the data could be consistently read as indicating that, while it does indeed contain iron, okay, there is some iron, along with other elements found on Earth, 90% of the sun is hydrogen, and most of the remainder is helium. Okay, so she is reinterpreting the data, and she thinks it's consistently telling us that it's hydrogen and helium, not iron. Most astronomers at the time dismissed Payne's interpretation, and some sought to explain it away simply by claiming that what she had examined was data about the sun's outer surface rather than its interior. So most astronomers dismissed her interpretation. They said, you have a mistake here. You're probably looking at something else. Absent a generally accepted explanation of how hydrogen and helium could produce the sun's energy, Payne's findings could not easily override her contemporaries' preconceptions. We now know, it's not the 20s anymore, we now know that the sun's heat is generated through nuclear fusion. The sun's gravitational force compresses together atoms of hydrogen, causing a nuclear reaction. So the compression, Kelvin was right about that, but it was compressing the hydrogen, which caused the nuclear reaction. This reaction produces enormous amounts of energy while forming helium and other elements. But this process, so well charted today that even elementary physics textbooks discuss it, was inadequately understood in the 1920s. Okay, the process wasn't understood in the 1920s. The emergence of that understanding, which relied on Einstein's equation governing the relationship between mass and energy, eventually provided strong confirmation of Payne's results. So Einstein's equation governing the relationship between mass and energy finally vindicated Payne and her results. Okay, so thanks, Einstein. Okay, so that's the passage. Let's just see how we might be able to sum the passage up, okay? It helps to sum it up in your own words so that you really know you have control of what's going on in the passage. Cecilia Payne took a close look at the spectroscopic data from the sun and concluded that it showed that the sun was made up mostly of hydrogen and helium. There's a little bit of iron, but mostly hydrogen and helium. The spectroscopic data supported this conclusion, but because the process of nuclear fusion wasn't understood at the time, no one could explain how a sun made of hydrogen and helium could generate all that heat. Other scientists didn't believe it. They were all convinced that the sun was made of iron, including Lord Kelvin, whose theory was that the gravity of all that iron has got to be squeezing it so tightly that that alone, that compression, generates heat. And Payne was finally vindicated when fusion was discovered, nuclear fusion was discovered. So basically, the passage's main point is about Payne's theory and how it eventually came to be accepted. Now, this passage is a really good example of competing scientific narratives. Sometimes it'll be a kind of they say, I say situation in which the author makes an argument that conflicts with other people's theories. And sometimes the author will showcase two or more competing theories about the same thing. You also may find that the passage charts a chronological development of scientific consensus, or maybe the lack of consensus, in a certain area of scientific inquiry. That's about it. We've summed it up in our head and are ready to go to the questions. Let's do it.